Okay, and we're back. So I've gotten my 8.3 data distribution notes because remember I told you that this third page right here was kind of like your cheat sheet. It was the best thing you would have ever seen in your life. So I'm going to have this out as I do the rest of these questions. So the first one says, if the mean is greater than the median, what type of distribution is this? So I come over here. Mean greater than the median is a right skewed distribution. Letter B. If the mean is less than the median, what type of distribution is this? Okay, mean is less than the median. Mean less than the median. You can see here in my picture, this would be a left skewed distribution. And if the mean, median, and the mode are all equal, what type of distribution is this? There's only one where all three are exactly the same right at the top of the peak. That is a symmetric or normal distribution. Libby says, number 2, Libby says a data distribution that is skewed right has a mean, median, and mode in the center of the bell curve. Find and fix her errors. Well, if the mean, median, and mode are all in the center, the only one that has all three of those in the center is a normal distribution or symmetric. Okay, if it is skewed right, then that means that the mean is greater than the median. So the only time that all three of them are exactly the same is if it is a symmetric or normal distribution. Okay. Number 3. Kind of got started on this one already just to help me out a little bit here. This looks very similar to the homework ones that we've done. So let's get started on number 3. Researchers asked 12 women and 12 men to report their age when they owned their first pet. Here is the data that they collected. So I've got the men's age and the women's age. For letter A, calculate the 5-number summary of the men's age data. Now, remember, in order to do the 5-number summary, you have to have your numbers in order from smallest to largest. It must be in order. So if you need to put them in order, do so. The 5-number summary includes the minimum, quartile 1, median, quartile 3, and maximum. So, minimum and maximum are easy. My minimum is 3. My maximum is 28. Now, my median is the one that's right in the center. So, if I work my way to the center, boom, 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 I see that the center is right in between 17 and 18. And so I have to pick the number that's in between 17 and 18. Well, that would be the average of 17 and 18, which is 17 and a half. Quartile 1 means the median of the first quartile. So again, I find my median and I notice it has to be in between 12 and 14. That would be 13. And then quartile 3, I do the same thing. It has to be between 21 and 22. And the average between 21 and 22 is 21 and a half. Now, to find the mean, I need to add up all of these data points. And so if I add them all together, I get 202. And then I divide it by however many pieces of data I have. And since I'm talking to 12 women and 12 men, I know I'm dividing this by 12. I do that and I get 16.8 with the 3 repeating. To find the standard deviation, I'm trying to find how far away is my average, or how far away are my data points from the mean. And we do this by going to an online calculator, which I have linked underneath in the directions for the video. My standard deviation, if I put these numbers in online, I get 6.87. The last one is my interquartile range. So my range from quartile 3 to quartile 1. To find that, I just subtract quartile 3 minus quartile 1. And I get 8.5. I'm now going to do the same thing for the next one. Again, must make sure that your numbers are in order from least to greatest. So I did actually have to rearrange these ones. My minimum is 9. My maximum is 27. I'm going to find my median by going to the middle. So the middle is right here between 17 and 19. That median is very easy. It would be 18. And then I'm going to find my quartiles. So the median for quartile 1 has to be between 13 and 15. That would be 14. And then the median of quartile 3 has to be between 21 and 23, which is 22. To find the mean, I add them all together. If I add all these data points together, I get 216. I divide it by how many data points I have, which is 12. I get that my mean or my average is 18. Standard deviation, again, I do this online. I get 5.26. And then to find the interquartile range, I do quartile 3 minus quartile 1, which is 8. So it's telling me that the average age of women who got their first pet was 18. It's telling me the average age for men was a little younger. It was about 16, almost 17 years old. Okay. Now, letter C, we're going to construct parallel box plots of the women and men's age data. So I'm going to do the men first. So you only use these 5 numbers here. Remember, at each one of these, you make a straight line, and then you just connect them. So for the men, their minimum is 3. Quartile 1 is 13. Median is 17.5. It's about there. Quartile 3 is 21.5. And then their maximum is 28. The 3 in the center are my box. The other ones are my whiskers. You can see that this one does not look like it's symmetric. It definitely has a longer tail over here on the left side. And now I'm going to do my women right on top. So I'm going to label this. This is my men data. Now I'll do the women. Zoom out just a little here. Okay, so my minimum is 9. Quartile 1's 14. 18. 22. 27. Here's my box. And you can tell that this one looks like it's pretty much the same on both sides. All right, so let's answer some questions about the data. Letter A. Does your data have any outliers? If so, what are they? So do you have something that is like crazy out of the way, like 100 more than another one should be, where all your data is? For the women, I would say everything looks pretty much symmetric on both sides. They look like you really don't have any. So that's women. For the men's data, it looks like you've got a really long tail, and then the rest of it is kind of more to the right side. So I would say that you might have one outlier for the men, and it's where your long tail would be, so at about 3 years old. Looks like your outlier. Letter B, describe the shape of each data set. Is it symmetric or is it skewed? So if I look at my women data, it's pretty easy to see that this is really very symmetric on both sides. So I would say that the women's data is definitely symmetric. The men, because they kind of have that outlier over here on the far left, you've got that long tail on the left. Because you have that longer tail over there, it does look like this would be a skewed data, and I would also say that it looks like it would be skewed left. Now, I will say that this men's data is not like crazy skewed. You might have a little bit longer of a tail, but not crazy much longer. So while technically I would say that this data is skewed, I would say it's not very far off from being symmetric. They're pretty close. When it comes to like quiz time, it'll be very, very obvious which ones are skewed and which one is symmetric. Letter C. How do the centers of the data sets compare? Which measure should you use to describe the center? So, for the women, my center, because this is symmetric, I'm going to come over here to my really great little thing. Because it's symmetric, the women's data is symmetric. To describe the center, I'm going to use the mean. The mean for my women's data was 18 years. 18 years old. Now, because the men's data is skewed, so the data is not symmetric, I'm going to use the median to describe my center. And the median for the men is about 17.5 years old. So it looks like the women's center is greater than the men's center. Last one, spreads. For the women, to find the spread, again, this is symmetric data for the women, so to find the spread, I'm going to use the standard deviation. The standard deviation for the women is about 5.26 years. So most of her data is very close to her center. For the men, because the men is not symmetric data, I'm going to use the interquartile range. The interquartile range for the men is 8.5 years old is their spread. So the women's deviation is smaller, which makes sense. If you have a smaller deviation, that means more of your data is close together. If you have a larger standard deviation or interquartile range, that means your data is more spread out. And that's exactly what I see here in my picture. So I see that the women's data is very symmetric. The men's data looks like it's a little bit more skewed. Okay. Last couple of questions here. All right. Use the dot plots to answer questions 4 through 9. A group of freshmen and sophomores were asked how many hours they spend on homework each week. How do the shapes of the data sets compare? So I'd say sophomores looks very, very symmetric. Freshmen look like their data is not as symmetric, does it? It looks like their data is pushed off to the left, and there's a very long tail over here on the right because of this one guy right here. So I would say the sophomores are symmetric, and the freshmen are skewed right. Do either group of students have an outlier? Well, an outlier makes you have skewed data. So yes, the freshmen have an outlier. And their outlier is at 10 hours. Which data set has the greater center? So if we're looking at center, if it is symmetric, we're going to look at the mean. So for the sophomores, the mean is right in the center here. It's at 5. Sophomores at. If we look at the freshmen, their center that we are going to use is the median, and the median is just a little bit further than where the hump is, so it's a little bit further. I'd say it's at about 3.5, 4, somewhere around there. The sophomores obviously have a greater center than the freshmen. Which group has a wider spread of data? Now, I can't look at this data and determine what the standard deviation or the interquartile range would be for each one, but I can look at my spread of data where it starts versus where it ends. If I include this outlier for freshmen, it looks like I go from 1 to 10, which is 9 hours, right? If I look at the sophomores, it looks like I go from 2 to 8, which would be 6 hours. So because of the outlier, the freshmen have a wider spread. Had I taken that outlier out, it would have been really easy to see that the sophomores have a wider spread than the freshmen. But because of this one little outlier, it kind of ruins my data. Number 8. Give one possible reason for the difference in centers for these data sets. So it looks like my sophomores have a center that is larger than my center for freshmen. Well, the question is talking about freshmen and sophomores were asked how many hours they spend on homework each week. Because sophomores are older, my guess is they're probably going to have harder classes, so they're spending more time studying. So they're older, so they have harder classes. And so they spend more time on homework. If I had to make a guess, but that's just a generalization. Last one, true or false? Ooh, that should say true, not true. The data set for sophomores is uniform. So I come back over here to my sophomores data. What I see is I have one peak. Uniform means straight across, no peak. So this is false. Because I have one peak, this data is considered unimodal. All right, last section here, 10 through 13. For questions 10 through 13, we're going to determine if each situation is likely to be uniformly distributed, normally distributed, skewed left, or skewed right. So it may help for each one of these to draw a quick sketch of the distribution. Okay, so I'll show you what I mean. The age at which people die in the United States. I want to know if it's uniformly, normally, or skewed data. So let's think about it logically, right? Excuse me. We'll say most people live to be in their, we'll say 100. So usually a normal person, right, by the average people, you're born, then you grow older, and then people start to die. Maybe there's a couple people that die earlier, but most people are dying in their, 80s, 90s, 100s, something like that. More people are dying at the right end than the left end. So because all of my data is over here at the right and I have a long tail on the left, this would be considered skewed left data or skewed left distribution. Number 11, number of pets owned by students at your school. So let's think about it. Let's say people probably don't have more than like 10, I would assume. We live in Florida. Most people probably either have 0, 1, 2, or 3, and then once you start getting to like 5, 6, 7, 8, 9, and 10, people probably don't have that many. So more people have less. So all my data is on the left side. I have a long tail on the right. This would be considered skewed right. All right, selling price of cars in 2018. Most cars sell between a 20 and 40 range, I would say. You don't really, if you're getting a new car. But remember, you've got some 70, 80, yeah, you know, you got some people who are making a bunch of money, can spend $100,000 on their car, but if I'm spending, this is in thousands, most cars are probably going to be around this 20, 30, 40 range, and then there will be some, but not many, that are going to be this expensive. So since most of your data is going to be clumped to the left, the lower end, and have a long tail on the right, this would be skewed right data. Last one, the height of all adult females in Connecticut. Well, you got to think, right? This is like where my 4 feet are. This is 5 feet. We'll say this is 5'5", and we'll say this is 6 feet. So you definitely have some people who are probably, you know, down here in the 5-foot range. You probably have, it grows, you get up to most people around 5'5", 5'6", and then you also don't have that many people who are really tall. So you don't have a lot of really short people. You don't have a lot of really tall people. Most people are considered right in this middle range. Because they're right in the middle, this looks very much like a mirror. So this would be a normal or a symmetric distribution. Okay. I believe that is it. So now that you have finished this, you are going to submit this into the week 5 video 2 study guide. This is all you had to do. There's no extra homework for it. It is just this. This counts as your homework. Notes counts as everything. So once you've completed this, submit it into the Edmodo assignment. And then remember, on Monday, May the 4th, you are going to have a quiz. Be prepared for it. You must show some work for it. So more of these like reasons. There are going to be a good number of questions that'll be like a fill in the blank sort of thing. So you're going to have to explain your reasoning for the problems. That will be on Monday. That quiz on Monday will be on Microsoft Teams. So just be aware that that's where that's going to be. All right. If you guys have any questions, reach out to me. And if you guys want to talk with me tomorrow on Friday live, we can talk live if you have any questions about any of these problems here. Okay, that's it. Have a grand day and a great weekend, and I will see you guys, or I'll talk to you guys soon. Thanks. Bye.